So we're going to review for the quiz today. Why is the mic on? Okay. So the quiz is tomorrow. The homework check is due tomorrow. I really need everybody to turn something in. We've done hit or miss some of the things on the homework check together. The quiz starts with 4.4a basic graphing, then 4.4b advanced graphing with phase shifts and writing an equation of a graph, 4.4c, which is modeling and doing a regression on the calculator for sine function, and then has the old stuff, 4.3, which I have an extra practice worksheet here on 4.3 with the answers on the back if you want practice on that. Those of you who did it last time and did poorly, it is the section where you use your unit circle and or you have to draw triangles in the right quadrant, okay? And then it ends with this section that's up here, 4.2, the formulas for angular linear velocity. There are 3 questions on this section. It has a arc length, an area of a sector, and an angular linear velocity. The only one I put on the review is an extra angular linear velocity question. The rest you can see the review from last time or your homework check from last time. What's the thing everybody got wrong? Anybody get one wrong on 4.2 that you remember? Sometimes you're given degrees. Can you leave things in degrees to use those formulas on your reference sheets? No, they have to be in radians. The formulas only work if you're in radians. So if I give you degrees, you have to multiply by pi over 180. Or if I give you, like on this one, revolutions per minute, and it wants feet per second. Should we go over this one, or you got this? 1200 RPM is not radians per minute. Okay, it is revolutions per minute. So what do we need to do? We're trying to get the linear velocity, so we need the angular times the radius. But the angular only happens if it's in radians. So what do we need to do to change this to radians? 1 revolution is 2 pi radians. Now it's an angular velocity. And so now we need to multiply by what? The radius is 15 inches. So now we have inches per minute, and for some silly reason they want feet per second. So what do we need to do? Okay. Inches, feet. What do you know? 12 inches is 1 foot. And that gets rid of inches. Now I have feet and minutes, but I want seconds. Where does minutes need to go? 1 minute is 60 seconds, so now minutes cancels. My labels are radians, feet, and seconds. The radians will disappear and you'll get feet per second. But this is a major typing concern for me because both of these are in the denominator. So you either have to divide twice or you have to type it all at once with parentheses. So we have 1200 times 2 pi, please type the pi in, times 15, and then you need to divide by 12 times 60, and if you're doing it all at once, you need to put it in parentheses. Did I remember the numbers right, guys? Okay. 157.1. On the quiz, it specifies not to leave things in terms of pi and to round to the nearest tenth. So this should be 157.1 feet per second. Pi answers, if you were, the one standing there looking at this wheel, pi answers don't mean anything. If you know it's going 157 feet every second, that gives you a little bit of an idea about how fast it's moving. Anybody else? Arc length or area of a sector, we good? 4.3 is also a review section. The two examples I put on here are not using unit circles. Yesterday in the other classes, I did some practice. I don't think I did on 4.3. Do you want me to talk about the more 4.3 worksheet I have for you, or do you want me to just pull up some examples? Or you don't want this at all? I have a warm-up here. What is it called? I have two of them. Okay. So here's what it looks like on the quiz. 7 pi over 4, is that on my unit circle? The ones I'm doing aren't on there. 7 pi over 4 is here. So what is the cosecant, guys? I flip over sine. Did I do some of these yesterday in this class or not? Okay. Which one's sine? It goes cosine, sine. Okay. Then I talked about this briefly in the other classes. Some of you went with this answer. Tangent is sine over cosine. That's true, but if you have something like 4/3, is the sine 4 and the cosine 3? What's the definition of sine, guys? It's a ratio of opposite over hypotenuse in a right triangle. Can the opposite be more than the hypotenuse? Picture the sine graph in your head. Starts at the origin, goes up as high as what? What's the maximum y value for a regular sine graph? 1. So it can't be that the sine is 4. Are you getting this? If you had this right triangle, it would have been the sine was 4/5, did Pythagorean theorem, and the cosine was 3/5, and when it reduced, it became 4/3. Okay? But I had people telling me that the sine is 4 and the cosine is 3, and that's not the case. They can't be more than 1. Okay? Back to this picture. I don't use this definition at all when I'm using the unit circle. Does anybody remember what definition we did use? Does that sound familiar? Put the y value over the x value, and the denominator will always disappear. Okay, so back to this question. This was a cosecant. So the sine at 7 pi over 4, by the way, if you practice writing the ordered pairs so I can tell what you did, that would be a good hint at where that you found the right spot. So then cosecant is the sine flipped over, so 2 over negative square root of 2. If you rationalize that, anybody remember what you get? You get just negative square root of 2, because this becomes 2 square roots of 2 over negative 2. These 2's divide out and just have negative square root of 2. All right, that was a long time on one question. I would change this to degrees. What's pi over 6, guys? Well, here, do 180 over pi if you want. What's 19 times 180 divided by 6? 5,700, or is it 5,700 or 570? 5,700? Okay. And then what do you have to do to get it down to something that's out of my unit circle? You just said 5,700? It was 570? Okay. So then if I subtract a 360, I'm at 210. So this was 570. We subtracted 360. We're down to 210. We go to 210. And the ordered pair is here. So we have negative square root of 3 over 2, comma negative 1/2. It's tangent, so it's the y value over the x, which is negative 1 over negative square root of 3, which is going to become what? Square root of 3 over 3, and it's going to become positive, yes? No? This is a review topic, guys, if you have not done the homework on this yet. Okay. Tangent at negative 45. Negative 45 would be here, so what's the tangent right there? Oh, you're really scaring me, guys. Y over x is negative 1. Secant at 13 pi over 3. I don't know, can someone do times 180 divided by pi would be 13 times 180 divided by 3, 780. If you take off 2 circles, you're down to 60. So it's really the secant of 60. So at this ordered pair, the secant flips over which one? Cosine, so it becomes 2 over 1 or 2. How are we doing? More? Yes, yes. Let me just do 1 or 2 real quick on this little slide I have, and then we'll do those, because those aren't using the unit circle. If I remember right, this one's a quadrantal. Negative 1020. Here you want to add 360s. I think you got to add 3 of them. If you add 360 3 times, what do you get? Guys, I'm kind of done with reviewing if you guys aren't going to participate. You get plain old 60. So this is really asking about the secant at 60. What is this secant? Flip over cosine, so it would just be 2. Okay, that's not the one I was thinking of then. I have no idea. Let's try this one. Times 180 over pi. So we have negative 11 times 180 divided by 3. And then add a couple 360s. And you also get 60. That one's not the one I was thinking of either, because the cosine of 60 would just be the x, or 1/2. All right, I'm just going to write one because I can't seem to figure out what I'm doing. What if it was cotangent of pi? Cotangent would be x over y. Negative 1 over 0 is undefined. Okay? What if it was the secant of 90? Okay? The cosine is 0, so what's the reciprocal of 0? Undefined. Still? We good? What about the tangent at 0 radians? Yes. Okay, got those quadrantals now? Anybody have a question? This is what I would practice on if you need more practice. There's a worksheet right here. Okay, the rest of that section is on, there's 2 questions where you have to draw, and I was asked to go over these. So this is the worksheet, the review. Left 21, up 20. So there's my bow tie triangle. Somebody do Pythagorean theorem for us, please. Thank you. I think it's 29. Is anybody getting that? Do you put, I wouldn't even bother to put the negative in, right? Can't have a negative number when you're doing Pythagorean theorem. Okay. So now what's the secant of that triangle? Well, cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, if you want to use that definition. Hypotenuse over adjacent. Hypotenuse is 29. Adjacent to the angle right here would be negative 21. Do you think signs might be a problem on those kind of questions? Watch your signs carefully. There's one more on your review that looks like this. Okay. This did not go well at all. I was very frustrated for students who got this wrong. What does this say? Okay. Cosine greater than 0 is positive. The cosine is positive. If the cosecant is negative 10/7, that means the cosecant is negative, which means the sine is also negative. Okay. All students take calculus. Where's the cosine positive and the sine negative? Boy, I heard different answers there. This means cosine is positive, everything else is negative. We good? Okay, this is quadrant 1, 2, 3, 4. Where am I going to put those numbers? I know this is a tricky question. There's a lot that can go wrong. It says 10/7 and one of them's negative. Yes, because cosecant is the flip of sine, so it's hypotenuse over opposite. Everybody with me? And can the hypotenuse ever be negative? No. So in this quadrant, the opposite here would be a -7. Do I need a negative on this when I do Pythagorean theorem? Sometimes I do, but in this fourth quadrant, I'm going to the right, so it's going to be a positive number. So I have x squared plus -7 squared equals 10 squared. I think you get 51. Square root of 51 that's 3 times 17. There's nothing that's a perfect square. So then we have the cotangent, which is what? Tangent is opposite over adjacent, so cotangent is adjacent over opposite. Lots of room for error on that question, yes? Please be very, very careful. Double, triple check that you've got your definitions right. Show all your work, so if it's wrong, I can go, oh, you did this, and I can clearly see what you did. All right. 4.4a is basic graphing. It's worksheet 11. I can't tell you highly recommend enough that if you have not done this, you do worksheet 11. These are some examples off worksheet 11. Is there anything somebody wants me to do, a particular question off worksheet 11? Or one of these examples of something? Yep. Is that one that you have to graph or just... And what does the graph look like? 0 to, what is it counting by? Does it have labels or not?
Yeah, it's pi, it's up to pi.
Oh, okay. So let me open that one then. I don't think I have that open. Worksheet 11, number 9. Homework question, please. I was thinking that, but it has, the worksheet has the actual graph paper here, so I found it. Number 9, right?
Yeah.
Okay, worksheet 11, number 9. Does it have this negative?
Yeah.
Okay. So it's supposed to be a negative sign. So if I were doing this on the quiz, I would make myself some notes. It's supposed to have this shape. Okay, what else can you tell me before you start it? Amplitude is 3. The what? Midline is down at y equals -1. So because they gave us graph paper, which I do not do on the quiz, guys, you get to draw your own. Okay, there's nothing. It's just a blank space. It's down at -1. It does not have a phase shift, so it's going to start at the midline. It's going to go down 3 and up 3, which will be at 2 and -4. It starts going down. What's the period, though? B is 1/3. Everybody good? So the period would be 2 pi divided by 1/3, or 2 pi times 3/1, or 6 pi. So it's supposed to go all the way out to 6. So where are the quarter points? 6 pi divided by 4 is every 1.5 pi, or 3 halves. So at 3 halves, it's going to hit the max, because this is the, oh man, just kidding. It's going down first. Good thing I wrote that little shape up there to remind myself. Then the next one would be 3 halves later, which would be where? If you keep adding 3 halves to that, you'd have 3 pi. 3 halves later would be 9 halves, or 4.5. This one is not there. And then 6 pi. It's much easier, in my opinion, if you don't have graph paper to try to match. But on the quiz, you would have to write those ordered pairs. I went over 0 and down 1. Then I went over 3 halves pi and down 4. Then I went over 3 pi and down 1. Then I went over 9 pi over 2 and up 2. And then I went over 6 pi and down 1. Questions? That was a great review question. It had a lot of good stuff going on. Does everybody understand that it's going to be blank? You can totally draw your own. Do we need to practice something more with quarter points or not? Number 2. Okay. The period here would be what? 2 pi over 4, which is pi over 2. The amplitude is 1/2. And it's a cosine, so it starts at the maximum. So it's going to start at 1/2. The quarter points are the period. It's always period divided by 4. So the period of pi over 2 is supposed to be divided by 4, or 1/2 divided by 4, or 1/8 of a pi.
I was right.
Okay.
The graph was huge.
Yes. So it's finishing a whole cycle by pi over 2 here. So at pi over 4, it would be down at -1/2. Pi over 8, it would cross in here and here. Yes, it is a tiny little graph. Because by pi, it's done 2 cycles.
I just thought it was
So the quarter points would be over 0, up 1/2, over pi over 8, up 0, over 2 pi over 8, which would be pi over 4, and down at -1/2, over 3 pi over 8, and back at 0, over 4 pi over 8, or pi over 2, and up at 1/2. Is that 5? Yes. 5 ordered pairs. What? Yeah, everybody okay? All right. The next section on the quiz is graphing with phase shifts and all that garbage. So tell me what I should write down about this graph before we start. What time is this class done? 11:25?
Yeah.
Sorry, my daughter's got some health stuff going on. Say it again. Phase shift, right, pi over 3. What else? Anything? Okay, vertical shift, up 1. So the midline is y equals 1. And as usual, we're going to get a great Hofbauer graph out of this. Okay, I'm just going to start that over because seriously. Trying to maintain here. Okay. It's up 1, but I got to go 4 more up, right? 2, 3, 4, 5, and down 4, which would be 0, -1, -2, -3. Okay. And it's going to start to the right, pi over 3. What else?
It's right.
Got that part. The shape is maximum to maximum, right? So it's going to actually start up here at 5. What's the period? Okay, it is 2 pi divided by 1/2, which is not pi. It's 2 pi times 2 over 1, which is 4 pi, which means the quarter points are 4 pi divided by 4, the period over 4, and that's pi. But how do you find them, actually, because of the phase shift? Yes, you have to start at pi over 3, or 1/3, and then put the pi on, and keep adding pi. So if we did it on the calculator, you'd type 1/3 plus 1, math, enter, enter, plus 1, math, enter, enter, plus 1, math, enter, enter. I'm going to try to do it without the calculator, so every pi is 3/3, right? So 1/3 plus 3/3 will make the next one 4/3, and another 3/3 after that would be 7/3, and then another 3/3 after that will be 10/3. Gonna get fired for being on my phone all hour. Am I missing one though? Yes. Don't I need one more or not? Okay. Thank you, smart board. Look at there. Okay. 13 pi over 3. This is not to scale at all, because this distance is a pi, and somehow this distance is 1/3 of a pi, right? Basically, this point right here, this pi over 3 should be moved over, and I can't. Okay. Doesn't matter. I'm worried about the ordered pairs. So starts at the max, then it hits the midline, then it goes to the min, back to the midline, up to the max. That's the worst graph ever. Okay. So the ordered pairs are over. Don't do the ordered pairs backwards, because I do sometimes. Over and up, over and up, over and down to -3, over and up, and over and up. It isn't going to be pretty, guys. When there's a phase shift involved, it is not going to be pretty. Okay? It's phase shift plus 1/4 of the period, then plus 1/4 of the period for the quarter points. You just keep adding. Anybody need to see it on the calculator, or are you good? Okay? In that same section is a question where you're given the graph. And it's labeled with ordered pairs, and it's quite likely not nice. Let's see if I can make this bigger. All right, you have it in front of you. Did I not say? I just wanted it sent here to this page. All right. Just trying to make it so that you can see it maybe a little better, but do you want to call, okay, first of all, 0, 0. This is the x-axis, or the y-axis. Yep, I know those difference. And that's the x. Okay, what do you want to find first? The midline, okay. So the y values range from 2 up top to -4 at the bottom. 2 plus -4 divided by 2 would be -1. So the midline is -1, it is down 1. What else? The amplitude, how far, if it goes up to 2, from -1, it's going up 3, and -1 minus 3 would be -4, which works, right? It's not -3, it's always positive amplitude, okay? The period is the length of one cycle, guys. I would start here and then say it finished here. I would probably call it a sine graph. You could call it a cosine. It doesn't matter. But that distance is the period for either one. It goes from 5 pi over 6, starting at pi over 3. So if we subtract to find the distance, that will be the period. On your calculator, 5/6 minus 1/3. It's 1/2. So that is half of a pi. Some of you are better with fractions than others. Hey, that's the period. What does that mean in terms of the equation? So B is the normal period divided by that period. B is plain old 4. Yes? No? Guys, worksheet 14 is all about this. Okay. The phase shift, are we calling it a sine or cosine? If you want to call it a sine, my green shape there is a sine shifted to the right. How much? So what's the equation look like? Y equals? B goes in there, and then another parenthesis before the phase shift. How are we feeling? Worksheet 14 is more practice on that. If it's really freaking you out, there's more practice in the bin over there. For, it's section 4.4b. All right, then there is the modeling section on the quiz. You have to choose one of these to write the equation for, and you have to do the regression. You want to do the regression? Yep. We are going to put into list 1 and list 2 the months. 1, 2, 3, 4, 5, 6, 7, and 8, I believe, right? You got to do them in order, guys. This is January through August is 8. So over here, make sure you don't go like back and forth or something silly. These got to match up. March, April, May, June. Okay, and I have not put them in. Brandon, you want to read them to me real fast?
Sorry, I'm not.
Oh, I'm sorry. Somebody got them?
55, 75, 190, 77,
100, 90, 77.
60, 80, 98.
Okay, proofread that you have them in right, because if you got them wrong, there's nothing gonna, I can't tell that later by your mistake. Okay, if you wanted to look at them, you would turn on the stat plot and do a zoom 9. All right, but the biggest thing, whether you graph it or not, is that you have to store the regression equation and use that stored equation in your table to find the prediction. So it's right arrow, stat, right arrow, up to sine regression or down. Leave iterations 3. If you have an older calculator, you won't have that. Make sure it's list 1 and list 2. Most important thing is you have to store it. It's either vars, arrow to the right, enter, enter, or it's alpha trace in choice 1. Now you're going to want to write this equation down. And then it should have stored. So you could check out the graph if you wanted, but really we just need to go to the table. And we are supposed to predict October, which is month 10. I have 68.7 reservations, I believe it is. If you round your answer and then type it in, because of all these decimal places, you're not going to get 68.7 and I'm going to count it wrong. Not lose a whole bunch of credit, but you're not going to get a 5 because I need to know. I don't really care how many places you write here because I'm hoping you're using your stored one anyway. Be careful, this does not have all the parentheses, this form notice. It is bx plus c with parentheses only once. All right, I used random number of variable or decimal places. Any questions? Okay, homework questions? Yes. That's a good question. The other classes asked that one yesterday, I think. The very first part of this worksheet 16, number 1, it says a Ferris wheel with a diameter of 100, which means the radius is 50, which means it's a big old Ferris wheel. 50 and 50. Completes 2.5 revolutions a minute. Okay, 2.5 revolutions in 1 minute. We're supposed to figure out the height of a seat as a function of the time. How much time does it take for 1 revolution? Okay, we need to divide this out so they get 1 revolution. I would not ask you this on a quiz, but I did it in seconds because if it goes around 2.5 times every minute, if we do it in seconds, that would make more sense. Otherwise, it would be 1 over 2.5 or part of a minute. So 60 seconds is 1 minute. So somebody do 2.5 divided by 60. Did I do that wrong? Oh, it's 1/24th. Okay, it's 1/24th of a revolution every minute. So how long does it take to do a revolution? A second. So 1 revolution equals 24 seconds. I did not explain that well. It's not that way on the quiz, I promise. Okay? We can go do the modeling questions next. But the period is 24 seconds. The amplitude, how far above and below they go on the ride, is the radius of 50 feet or meters or whatever it is. Are you good then? I think it says he starts at the bottom. Does it say he starts? Starts 4 feet off the ground going up. Can you get it from there? Okay, because I want to do, this one doesn't have a phase shift. I'm going to run back here and quick do the 2 on the here. Okay, the height of a spring varies sinusoidally with time. Please read carefully because these do not give you a full period necessarily. And they, I think, both have a phase shift, not positive. The height of a spring varies sinusoidally with time. After 3 seconds, the spring reaches its height of 74 centimeters. So there's an ordered pair. This is the sentence that messes everybody up. Then 5 seconds later, it reaches 12 centimeters, the low. 5 seconds later is what? At 8 seconds, it's at a low of 12 centimeters. Is that a period? It's half a period, right? I don't care about your graph as much as your equation. It would take another 5 seconds to get back to the max, which would be at 13. basically, as soon as you knew that 5 was only half a period, you knew the period was 10, right? What else do you know? Midline? 74 plus 12 divided by 2 is 86, is 43, I think. That's going to go on the back. I'm going way too fast. The amplitude, how far above and below 43 does it go? 31 and 31. So the amplitude is 31. What do you want to call this? A cosine. Shifted to the right 3, I'm thinking. It's a plus 43 on the back. And in here goes 2 pi over the period, or pi over 5 if you want. Then you could graph it, right? And I could ask you, where's he at 6 seconds into the ride or something. I'm not even sure you have to do a prediction. But I'm going to run out of time, so I'm going to do the last one. Check. Okay, I'm going fast because her lunch is over at 11:30, so I need to run out and try to catch her. Distance the tip of the red peel was from, okay. Did you read the question, guys? I think this goes negative. Its highest is 8 inches. Okay. There's water here. It goes 8 inches above, but the whole diameter is 24 inches.
That's.
So
It's 12, which is the
8, wait a minute. 8 above minus, okay, 24 from 8 is negative 16. Okay. So the paddle wheel comes 8 inches out of the water or goes 16 inches in the water. When the stopwatch read 2 seconds, it was 8 inches above. In another 18 seconds before it reaches that height again. So it goes, 18 seconds go by, which would be at 20 seconds, it's back at 8. But it goes down in between there. The diameter is 24, okay? So what's the amplitude? 12 and 12, which makes the midline where 12 above this would be negative 4. Okay, so the amplitude was 12. I'm going to call it a cosine that has shifted to the right 2, and the midline is at negative 4. The period is 18, so 2 pi over 18 would make this it's seconds. This is seconds. Okay. So be ready for the quiz. Do the homework check. Video done.